So we have a vector problem here that we're going to do. It's dealing with a captain and a boat. And I've already done a grid in pencil for my north-south line and my east line. It says the captain of a boat is steering at a heading of south 57 degrees east. So south 57 degrees east, and we're going at a speed of 18 miles per hour. So I'm going to go ahead and draw that line in here. And then we have the current, and it's flowing at a speed of 4 miles per hour at a heading of north 30 degrees east. I should put this in here. This is 57 degrees. And then we need north 30 degrees, and we're only going 4 miles per hour. So see how long this line is here. We want the other line to be about a fifth of the length of this line right here. So we're trying to do it to scale. So there's my 4 miles per hour. And then this dimension right here is 30 degrees. Then it says to find the course to the nearest degree and the resultant speed to the nearest tenth of a mile per hour of the boat. So my resultant then, using the parallelogram method, I'm going to draw the other side of my parallelogram here. So there's the other two sides of my parallelogram. And then I'm going to draw my resultant, which starts at the initial point of the other two vectors and ends at the diagonal corner of my parallelogram. So this is my resultant vector. So now, using all this information, I can figure out what my vector for my current is, and I can find the vector of what for my boat, and the two of them added together. So the vector for my resultant is going to be the vector of my current plus my vector for my boat. So I need to figure out what the vector for the current and the boat are. The vector for the current is going to be the magnitude of the current, which is 4, times the cosine of the angle between my vector and the positive x-axis. So the dimension of that angle right there is 60 degrees. And then I'm going to have the sine of 60 degrees. The magnitude for, my vector for my boat is going to be the magnitude of the boat speed, so that's the 18. And then from the positive x-axis, I'm going to be going around 270 degrees plus another 57 degrees. So that ends up being the cosine of 327 degrees. And the sine of 327 degrees. Then I'm going to be adding these two vectors together. So to find my resultant vector, I need to add the first components of each of the vectors and then add the second components of each of the vectors. So adding the first components, I have 4 cosine 60 degrees plus 18 cosine 327 degrees. And then for my second components, 4 sine 60 degrees plus 4 sine 327 degrees. Using my calculator, I end up with my resultant vector having coordinates 17.0961, and the y-coordinate is -6.3394. So that means that my resulting vector is going to be 17 units in the x direction minus 6 units in the y direction. To find the magnitude, to find my magnitude of my resultant vector, I need to take the magnitude in the x direction, or the vector in the x direction, and square it, plus the y direction vector squared, and then take the square root of that. When I do that, I end up with 18.23 miles per hour, and then rounding to the nearest tenth gives me 18.2 miles per hour is my resultant speed, including the current. Then to find the angle that it's going to make with the positive x-axis, I'm going to take the arctan of my y vector, -6.3394, divided by my x vector, 17.0961. when I take the arctangent of that, I end up with negative 20.345 degrees. And that is the distance from my resultant vector to the positive x-axis. So that's this dimension right here, is negative 20.345 degrees. And what I need to find is the distance from due south to my vector. So this is what I need to find. So to find that, I'm going to add 90 to negative 20. So 90 minus 20.345 degrees gives me about 69.7 degrees. And then rounding to the nearest degree and rewriting it using my bearings, it's going to be south 70 degrees east.